peregrine falcon, t seconds after it starts diving down towards its prey, is modeled by this function. Okay, now I've heard some really good questions. And one question is, how is it that the flight of this bird is modeled by this function? And when you graph it, and I don't have it in my calculator right now, so I'm just going to do a sketch. I know that it's going to be negative, and I know that it's going to look something like this. All right? I'm not quite sure where it's going to be, but it's going to be facing downward. Because this is t seconds, does it make sense that we're even interested in this side of the graph?
No.
No, we don't have negative time. So we know that we're only really interested, actually this isn't quite accurate, it's probably more like that, because he's starting at the maximum and coming down. Okay, so this is what we're interested in, and it happens that this equation models the time in seconds that it takes the height and feet of a peregrine falcon, t seconds after it starts diving toward, is modeled by that. And that's all it is. So we can say, well, after 2 seconds, it might be here. After 3 seconds, etc. What?
But shouldn't it get steeper because doesn't it go faster, like farther on?
Well, that's actually a good question, Mike, and that is a question I believe that we'll talk about in question number 7. So we'll come back to that, because you would think that maybe it would speed, but what is this bird going to do?
Slow down.
Because,
It's landing.
yeah, it's landing. So you think it's just going to go, oh, no, probably not. It probably ends, okay, so you need to understand, that models the flight or its height after t seconds. But you're absolutely right, there may be a slight change. And what else do you have to take into account? Not only the fact that these might slow down. What?
Wind speed.
Well, yeah, resistance. There may be air resistance that will be impacting. So, all right. So, graph the function that shows the height, and you needed to experiment with that. And some of you seem to have had a hard time with that. Did you come up with a window that worked? Anybody want to share what they used for a window? Stephen?
Well, I did zoom fit, and then I fiddled with it to make it actually whole numbers, because when you fit it, it makes decimals.
Okay.
So I used x min was -10, x max was 10, and then x min was -500, and x max was 1,500.
And when you did, do you want to show people how you did that, please?
Should I
Just put it right here, under here, so people can see what you've done. So you.
That's what I ended up with.
That's what he ended up with. And you can.
I didn't even go into the negatives for the y, because I figured once we hit the ground, it didn't really matter.
I know,
what it
I-
was.
Okay, you're absolutely right. You don't need to. But can you show us your window?
Yeah.
What did you start with?
What did I start with?
Can you go to Zoom standard? Zoom standard 6. Okay, so it's not even on the screen.
That's what I did.
So Emily, here's what you need to think about. Okay, so if you want to show the zoom fit and go to, what number is that? 10?
Zoom fit, I think it's number 10.
I think it's 10.
And then you get up with that. But then when you go to your window, it's all decimally, so you have to fix it.
Okay.
Decimally.
So that should be fairly easy for you if you can't get there. Okay? All right, good. All right, so are we good with how to get a graph, how to look at the data? All right, now let's look at number 2. Write a quadratic equation. We're looking for an equation now that shows that the height of the falcon is 500 feet. All right? Use the zoom and trace features to find an approximate solution to this equation, and what does the solution represent? Anybody have that still on their calculator? You wrote it down?
Maybe.
Let me see if I can do this quickly. Do I have it on? Clear. So equals what, negative 16x squared minus 53x plus 1,000. What does it mean that we're going to, yes, do you have it, how did you do the 500? We're working on number 2. Write on a quadratic equation that shows the height of the falcon is 500 feet.
Oh, I just put in y equals 500. So that
Okay,
made
but
a line.
what would the equation be?
Oh, 500 equals
500 equals, remember, we're saying that 500 equals negative 16t squared minus 53t plus 1,000. Do we know what the value of t is? We don't know, but we know that there will be a value, or 2, that will make that a true statement. And in this particular case, were there 2? Do you have that on your
Yeah.
calculator? We should see that. Thank you. Okay, so we have 2 values, but do we want 2 values? No, because the values on the left represent what? Negative. And is that a solution for a falcon, the time for him, for that altitude? That doesn't make sense. Okay? Okay, good. Let me just say. All right, so change your viewing window so that x ranges from negative 10 to 10 and y ranges from 0 to 1100. What does the graph of the function look like now? I just use yours since yours is,
Yeah.
this is it actually.
Because I think it might still be set up from them.
And the range is from 0, yeah, this was her graph for that. And let me see. Use your graph to find all of the x values that solve your equation. And we can do that. There are 2 ways. I showed you how to do it by just saying, well, when y is 500, what do? We're just looking for those points of intersection. All right, what is the other way to do that? If we, I'm going to erase something, all right? So if I had used this, and I had cleared that, I'm going to actually show you no, I'm not. I thought I was going to do something. So if I want to find the x value, and I didn't plug that in, what could I do?
Can't you just like type in number or something? There's a way to
That will
search it.
give me, if I want to know, if I know
Oh, if
the
you go
x
back.
value. Okay, and this is what Cassie was just saying. If I want to know, if I hit, what was it, trace, calc, my second calc here. If I know an x value and I want to know the y value, I can just plug in, well, value when x is, let's say, 5 seconds, it will tell me, can you see that, the spider? It's right over there. It will tell me after 5 seconds the height of the falcon is 335 feet. But in this case, I didn't know the x value. They were asking me for, they gave me the y value. So could I have done a trace and kept going until I found when y was, I mean, I could just go, and to me, whoops, what am I doing here? This is a lot, you know, it's going to be somewhere in here. Where else could I look? On the table. Okay, I could go, what is it, second table. My table comes out, and so I can see that it's going to be between 3 and 4. So, I mean, all that information is right there. You just need to think of looking there. Okay? Somebody have their hand out?
Yeah, I did, but
Okay.